So last week you practiced multiplying a monomial times a binomial, and we just used the distributive property to distribute out the monomial to each term in the parentheses. So let's go ahead and talk about what each one of these was. This first one was a monomial because it's just one term. And then the parentheses would be a binomial because there's two terms. And I know that because it's separated, the 3x and the 4 is separated by this plus sign. A monomial is when everything's multiplied together, it's one term. And a binomial is separated by addition or subtraction. So if I were to multiply these like we did last week, let me just go ahead and do one of these examples. I would multiply or distribute 2x times 3x, and I would get 6x squared. And then I would distribute and multiply the 2x times the 4, which would give me a positive 8x. So my answer would be 6x squared plus 8x. But now this week, we're going to start multiplying a binomial times a binomial, which is something you have never done before. So now we are going to multiply a binomial times a binomial, which just means you have two terms times two more terms. We're still going to use the distributive property, but you have to multiply each term in the first parentheses by each term in the second parentheses. So let's go ahead and take a look at what that would look like. I'm going to multiply this first x, which I'm circling in red, by the first x in the second parenthesis. So x times x is x squared. And then I'm still going to stay with this very first x that I'm now coloring in blue, but I'm going to distribute or multiply it to the 3 in the second parenthesis. So x times 3 is 3x. Now I'm going to move to the 2. I'm going to distribute out the 2 to each part of the second parenthesis. So I'm going to multiply 2 times x. 2 times x is 2x. And then the very last step would be to multiply your last terms. 2 times 3. So 2 times 3 is 6. So you can tell that each term in the first parenthesis has been multiplied by each term in the second parenthesis. Now we need to combine our like terms and simplify this polynomial expression. So I would have x squared, then 3x plus 2x. Since they're both x terms, I can add them together. 3x plus 2x is 5x. And then I would have plus 6 at the end of that. You cannot add a 1, a 5, and a 6 together. Each one of these is a separate term. Your answer would have to be x squared plus 5x plus 6. So we solved this problem using the distributive property, but there's actually another way that I like to use called the box method. And this method is for people who are visual learners, and it kind of helps you stay more organized. So let's go ahead and do the box method and see how it compares to the distributive method. So since I'm multiplying a binomial times a binomial, which is 2 terms times 2 terms, I need a 2 by 2 box. Then I'm going to put each binomial along the length and width of this box. So let's start with the x plus 2. I'm going to put each term outside of each box. So x plus 2 I put along the length, and then I'm going to put x plus 3 along the width. And I could have switched those. I could have put x plus 3 along the length and then x plus 2 along the width, and you would still get the same answer. So now I'm just going to multiply each column by each row. So let's start with the very first box. X times x would give me x squared, just like what we got with our first step whenever we did it above. Now I'm going to multiply x times 3, which we know is 3x. Then I'm going to multiply the x and the 2, which would give me 2x. And then the very last step, I'm going to multiply the 2 times the 3, which would give me 6. So as you can see, we get the exact same numbers. This is just lined up in a nice, neat, pretty box. So whenever I go ahead and simplify this, I still get 1x squared. I can tell that my diagonal contains my x terms, so I still have a 2x and a 3x. So when I combine those, I would get 5x. And then I would have a plus 6 at the end. So whichever method you choose, you would get the exact same answer. It just depends on if you like the box to help you stay organized or if you just want to use the distributive property. So now let's look at some of your IXL examples. This time we're multiplying k minus 2 times k plus 1. So we still have a binomial times a binomial. Let's go ahead and use the distributive property first, and then I'll show you the box method. So we're going to start with this very first term and distribute it to each term in the second parenthesis. So k times k would be k squared. And then I'm going to multiply k times 1. So k times 1 is just k. And then I'm going to move to the second term. Negative 2 times k would be negative 2k. And then the very last terms, negative 2 times positive 1 would be negative 2. So whenever I simplify and combine my like terms, I would get k squared. I can combine these k's. This is really like 1k minus 2k. Well, I know 1 minus 2 would be negative 1, so this would become negative 1k, or just negative k, and then minus 2. I'll also show you what the box method would look like if you wanted to use that. So draw a 2 by 2 box again. I'm going to put k minus 2 along the length and k plus 1 along the width, and then just multiply each row by each column. So k times k would be k squared. K times 1 is just k. Negative 2 times k is negative 2k. And then negative 2 times 1 is negative 2. So if I were to simplify this, we would get the exact same answer as what we just got. K squared, then 1k minus 2k would give me negative k, and then minus 2. So whichever method you use, you should still get the exact same answer. Alright, moving on to another example. This time I have r minus 3 times r plus 3. Okay, I'm not going to use the color coding anymore, so bear with me. We're going to start with the very first term and distribute it out to each term in the second parentheses. So r times r is going to be r squared. Then r times 3 is 3r. Okay, then I'm going to move to negative 3 and multiply everything in the second parentheses by negative 3. So let's start with negative 3 times r. Negative 3 times r would be negative 3r. And then negative 3 times positive 3 would give me negative 9. So if I simplify this, I would get r squared. Then I have 3r minus 3r. Well, 3r minus 3r is just 0. So I don't have any more r terms. And I would just be left with r squared minus 9. Okay, let's put it in a box and see what that would turn out as. So I'd put r minus 3 and r plus 3 along the length and the width, and then multiply each row by column. So r times r is r squared. R times 3 would give me 3r. Negative 3 times r is negative 3r. And then negative 3 times positive 3 is negative 9. So I can see again that I would get r squared. 3r minus 3r is just 0, so you don't have an r term. And then you'd have minus 9. So my answer would be r squared minus 9. Okay, we're getting a little bit harder. So I'm going to still distribute out this very first term to each number in the second parenthesis. So this time I'm starting with t times 3t. T times 3t would be 3t squared, because 1 times 3 is 3, and t times t is t squared. Then I'm multiplying the t times positive 1, which would just be 1t. Then I'm going to move to the negative 3 and distribute the negative 3 out to each term in the second parenthesis. So negative 3 times positive 3t would become negative 9t. And then negative 3 times positive 1 is negative 3. So let's combine our like terms. This would become 3t squared. Then I've got 1t minus 9t. Well, 1 minus 9 is negative 8. So this would turn into negative 8t minus 3. So my answer would be 3t squared minus 8t minus 3. Okay, if you don't want to see the box method, just fast forward through this. But for those that do, I'm going to show that again. Okay, it doesn't hurt to get some extra practice here. Alright, so I drew my box. I put t minus 3 along the length and 3t plus 1 along the width. And then just multiply it out. So 3t times t would be 3t squared. T times 1 would be t. 3t times negative 3 is negative 9t. And then negative 3 times 1 would be negative 3. So I can combine my like terms. I can see I would still get the same answer. 3t squared minus 8t minus 3. The box method kind of reminds me of like a Punnett square. You know, you have like hereditary traits where you have a dominant and recessive trait. I think you've done Punnett squares in science before. So anyways, side note, that's kind of just what it reminds me of. Alright, moving on to another example. Alright, this time I have 3d minus 2 times 3d minus 4. So let's use the distributive property. I'm going to distribute out this first 3d to each number in the second parenthesis. So 3d times 3d, well 3 times 3 is 9, and d times d would be d squared. Then 3d times negative 4 would be negative 12d. Moving on to the next term, I would distribute the negative 2 to each number in the second parenthesis. So negative 2 times 3D is negative 6D. And then negative 2 times negative 4 is positive 8. So last up, let's go ahead and simplify. I would get 9D squared. Then I need to combine my D terms. Negative 12 minus 6. Negative 12 minus 6, or negative 12D minus 6D would be negative 18D. And then plus 8. So my answer for this product would be 9D squared minus 18D plus 8. Alright, one last time I will show the box method. 3D minus 2 times 3D minus 4. So 3D times 3D is 9D squared. 3D times negative 4 is negative 12D. Negative 2 times 3D is negative 6D. And negative 2 times negative 4 is positive 8. So I would still get 9D squared minus 18D plus 8. Alright, I know that was a lot to learn, but you can do it. Hope you guys have a great week, and don't ever hesitate to call or text if you've got any questions. Bye.